Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 4th, 2026, about 3 days ago. It introduces a unified multimodal model that performs end-to-end transcription and speaker identification, utilizing a massive 128K context window to process up to 90 minutes of audio in a single pass. The paper is titled, "Moss Transcribe Diarize, Accurate Transcription with Speaker Diarization." And, as we'll see later, the results show it outperforming major commercial systems on difficult, long-form benchmarks. So, Figure 1 breaks down the system's 4 key capabilities. Starting in the top left, the model produces fully time-stamped segments with precise start and end times, alongside stable speaker identities. Moving to the top right, it handles multilingual content, automatically detecting language changes while keeping speaker tags consistent. Then, down in the bottom right, the diagram highlights long-form processing, specifically maintaining accurate tracking over hour-long recordings. Finally, on the bottom left, we see it can also tag non-speech events and manage overlapping dialogue. Alright, Figure 2 illustrates the overall architecture, which is streamlined for end-to-end processing. On the bottom left, raw speech input passes through a trainable audio encoder. These features flow into the central autoregressive speech, MLLM, shown in the large gray block. The critical innovation appears in the output sequence at the top. Here the model generates a structured pattern for every phrase, a start timestamp, a speaker tag like S01, the spoken text, and finally an end timestamp handling everything in one pass. Well, now that we have the architecture down, Table 1 lists the specific datasets used for evaluation. The first two, A-Shell4 and Podcast, represent long-form audio, with average durations exceeding 2,000 seconds and involving up to 11 speakers. Conversely, the movie's dataset in the bottom row consists of very short clips, averaging about 11 seconds, which isolates the model's performance on quick, overlapping dialogue. So, Table 2 reveals how the model stacks up against commercial heavyweights like GPT-4o and Gemini. The table reports error rates, so lower numbers are better. Notice the backslashes in the middle columns for the first two datasets. Those major models actually failed on the long audio inputs due to constraints or instability. In contrast, the far right column shows Moss Transcribe Diarize handles everything successfully. It consistently achieves the lowest errors, for instance dropping the speaker attribution error, or CPCER, to under 7% on the podcast benchmark. Wrapping up, 2 takeaways stand out. First, the shift to a unified end-to-end model eliminates the error propagation typical of modular pipelines. Second, the massive 128K context window effectively solves speaker identity drift in long meetings. This sets a robust new baseline for conversational analytics. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.